So thus far, we've seen that the binomial distribution arises serendipitously, for example, in the analysis of polls, in the testing of saline vaccines, in sundry problems in the throwing of dice, in cards, and of course, in the tossing of a coin. But if we want to go beyond a qualitative understanding of where the distribution arises, go beyond a subjective feeling of, well, this seems to fit the problem well, and get to a position where we have a quantitative understanding of what is going on. If we, for example, want to give certain guarantees on how well we estimate something, we are going to have to dig deeper into the mathematical innards of the distribution, of the particular function that it comprises the binomial. So accordingly, let's jump right in and start with an image that we have seen before. So on the screen you see examples of three binomial distributions. We have fixed the number of trials at n equal to 100 and varied the success probability from 0.3 to 0.5, that is to say a fair coin, to 0.8. And the mass functions are plotted on the screen for you. Now, when one looks at this particular graph for these mass functions, we see that certain characteristics sort of jump out at us. So, in particular, it seems to be clear that these atomic masses sort of increase gently, reach a maximum, a crescendo, and then sort of decrease gently. In other words, they have a unimodal character, something like an Arabian camel. Right, of course, in this metaphor, a Bactrian camel would be bimodal, and I guess an alien camel from somewhere else could be multimodal. But we are dealing with an Arabian camel, a single mode, one maximum. There are other features that are also seen to be evident in this kind of picture. For instance, there seems to be a centering tendency. So pick a distribution, let's say for p equal to 0.5. It looks clear that the masses are centered around 50 successes, right at the midpoint, and they seem to be distributed reasonably evenly on both sides. Now, when the coin is fair, when p is 0.5, this tendency is very clear. In fact, there's complete symmetry on both sides of the center. But this kind of overall general symmetry seems to be also persistent when p is 0.3 and p is 0.8. In other words, the masses are spread reasonably evenly around a central point. There is a centering tendency. Still another point that might come to our attention is that the spread of likely values for the accumulated number of successes is spread fairly tightly around the central area. Yes, in 100 tosses of a coin, it is possible to get no successes whatsoever, but the probability is minuscule. It's really tiny. Most of the mass seems to be concentrated around the center. And so there's an idea, a notion of a spread or a dispersion around the center. And finally, and this conclusion seems inescapable because of the graphic demands of the figure, there appears to be a generic bell shape to the distribution. If you connect the dots, as it were, we find that a beautiful little bell curve emerges. None of these are serendipitous or accidental. And so we will examine each of these features one at a time, but defer the last, the bell curve, the most important of them all, for a subsequent tableau. And in fact, it is so important we should devote our concluding tableau just to that one issue. So we'll focus for the nonce on our observed unimodality as centering tendency and the nature of the spread around the center.